All right, so man, time just really flew by whenever we're trying to fix up all those misconceptions with class. Like I said, tomorrow's assignment where you guys are alone really has a lot to do with our notes that we're going over today. So I wanted to finish that up and not leave you guys hanging. Evaluating functions. Our goals for today were to learn about function notation, evaluate a function using a table, using a graph, and also trying to figure out the difference between continuous and discrete, because those two words, oh my goodness, they are always messed up. All right, so we have, here we are, Lucky, real cat. He decides to go to the store, buy some cat treats, you know, normal cat stuff. And he decides to get these expensive bougie treats that cost $2.50 a whole bag. All right. So what we're going to do is help Lucky out because times are hard for a cat. And we want to build a table. So on your own piece of paper, if you have one available, let's go ahead and draw out a table. Yeah, why not? So here we go. Actually, I'm going to draw over here where I have a little bit more space. All right, it's going to come out in red. All right, there's our table. Okay, I think I'm going to have to move my face over a little. Maybe shrink me up. There we go. Oh, look at me, I'm tiny. All right. So usually what goes in here is X. And that means over here is our Y. Now, like I was stating in the video yesterday, we were talking about inputs and outputs. Now, in this case, our input in this situation, well, that should be our bag of treats. That's most likely our X. Because as this changes, that affects my cost. So let's take a look at that. Oh, there we go. And I'm going to erase that nastiness over there. There we go. All right. Now, again, this is where my technology started messing up, and I'm so sorry about that. So you guys wanted to start big, like buy all the treats. Why not? But then you scaled it down just for me. Thanks. I appreciate it. And so given that Lucky goes off and buys just one bag of treats, that would cost, and you know what, usually I like to say over here, number of, there we go, because I'm being really specific, it's one. Okay, so number of bags of treats, one bag of treats, and my cost, I usually like to put in parentheses my unit of measurement. Oh, that looks ugly. Okay. Try and pretend that that's a dollar sign, y'all. Okay, it's money, I promise. So one bag of treats that costs, because I don't want to have to write that ugly dollar sign like a million times. That's a period, not a comma. Sorry. There we go. $2.50. Now, please tell me, did I have to write that zero at the end? No, oh God, don't make me have to write that again. So then y'all told me that if Lucky bought 2 bags, man, you guys were so smart. I love it. And shout out to, you guys told me of one of your teachers, Miss Macias, because you guys came over super prepared. All right. So, y'all told me that it would be $2 or 2 bags would cost him $5. Whenever I ask what the function y'all doing, you guys are telling me that you're multiplying numbers. And I'm like, awesome. Okay, so let's go ahead and continue. Now, we were talking about functions at the beginning of the class. Now, given this information right now, given this table, would you guys say function or not a function? I think I would say it's a function. Why? Because of my x values. My x values are not repeating, not at this point. So, function. All right, continuing. All right, so Lucky wants to know how much it would cost to buy 3 bags of treats. Now, this is where you guys, like, you already did the math because you guys were multiplying for me, doing all sorts of crazy stuff. Now, what I want you guys to think about is this new way of thinking. So you guys already knew the math. You guys figured out it didn't take very much to figure out how much 3 bags of treats would cost. Now, what I want to start doing is rewriting it and adjusting and tweaking your brain a little as to how you interpret this. Now, y equals, remember, on a table, y equals, or y on a table would be on this side, right? Because that's our output, just like we had earlier. And our x, well, usually that's on the left side because that's my input. Okay, let's clear that off here. So our new input here is going to be our 3 bags of treats. And that's what we were seeing, that's what we were building up to on the table. And I know that you guys already figured out what that answer would be. Now, do know, on a table, you could write x and y. Whew. Or you could write, and you guys saw this on some of the tables that I gave you yesterday. You could have an x here, and then this weird notation, f of, that's what those parentheses are, x. Try and like, I'm holding my breath. Okay. F of x, those parentheses, every time I see those parentheses, I want to think of, okay? It doesn't mean multiplication. You're not going to say F parentheses X. I'm going to punch you in the face. Don't do that, okay? I'm not, I promise. Not until you guys are seniors. Don't worry, I'm nice to my freshmen. So you can either write Y or you could write F of X because they mean the same thing, all right? Now, let's see. Let's erase a little bit of that junk, huh? There we are. So remember, Y and F of X, they both mean output, okay? Anywhere you see F of X, you could write Y instead, and vice versa. If it says Y equals 7, you could write F of X equals 7. They're interchangeable. All right, so let's try this out. We're going to do some rewriting here. I'm going to give you these two. There we go. It's taking a little while for it to come out. These two problems. So what is Y when X is 7? So to write that out, let me get a different color because, yeah, come on now. I love color. Can I make that any thicker? No, I can't. All right. So what is Y? So I want you to think of is. Always remember that means equals. Okay. So whenever it says this, what is Y? So your answer, think of like Jeopardy, Y is. You're going to take it and go backwards. Like what is? All right. So whenever it says what is Y, we're going to flip it back on them and say Y is. So what is Y when X is 7? That means F of 7. So the way that we can write out this statement, this verbal statement into a mathematical statement, we kind of flip it around a little and we say Y is, and then remember, this is our input, so we're switching out our X with a 7. And there it is. So what is Y when X is 20? So again, we would take my is and my Y and we flip it. And then this is my input. So if we were to do that, obviously we would get Y is equal to F of 20. Now, right now, we're just working on kind of converting words and math and words, because I know that that's where a lot of things get pretty confusing. All right. So we're going to rewrite Lucky's situation using function notation. So the question here is, what is the total of 3 bags of treats? So if you think about it, remember our total cost, that was, like, if we have a table here, our total cost was over here, right? You know what? I'm going to switch that. Let me erase that part. Because that was our money. God, that looks so bad. And then over here, that was the number of the bags of treats. Oh God, that's looking awful. Okay, you guys know what I'm trying to say there. Now that should say treats, I promise. So if my total cost, if this, let's just erase that horrible mess. If my total cost is Y, so it's asking, what is Y? And then over here, my bag of treats, that's my X, isn't it? Which is 3. And that kind of sounds like what we were doing earlier, right? So what is Y when X is 3? So we already know what that's going to look like. So it says Lucky's question in function notation, it would be f of 3. And this is kind of our completed table that we had at the beginning. So here we have the bag of treats, it's 3, and our total cost, that's $7.50. You guys already knew that. So this is something new. The way we would write our answer, f of 3, that means y, is equal to 750. So that's kind of saying like y equals 750. But it's even more specific, and it's saying, I'm not going to write the 0. It's saying y is 750 when x is 3. So all of this right here, f of 3 equals 750, it has a bigger sentence. It says y is $7.50 when they buy 3 bags of treats. I love it. All right. Because I'm super lazy and I hate to have to write things a whole bunch of times. Shrink myself again. Now, in this case here, we have my input is, it looks like number of days, and my output is water level, which is y, or f of x. And in this case, it says my water level in a river is, so my water level, it looks like it's at 34 feet, and it is receding at a rate of receding. Oh gosh, that's a big word there. So that word, receding, means to go down. Maybe you guys have heard that word for a receding hairline. That means that they're getting less hair and it's kind of going back. So instead of your hairline being up here, it's going down. It's going way back. All right. So receding means to go down. In that case, I would say that my first day, I'm going to say that that's actually 0. Okay. 0 is going to mean initial. So I initially, let me put that. Let's take a minute to try and draw that one out. That's going to be my initial amount there. So whenever you have an initial amount, it's always going to start with 0. All right. So initially, the amount of water I had was 34 feet. So I'm going to put that 34 there. After one day, if it recedes at a rate of half a foot per day, well, after 1 day, shouldn't that be, ooh, that looks bad, 33 and a half? Okay. How about after two days? Because that's what we need right there, right? So after 2 days, we would take off another half, and that would be 33. Now, so in this case here, I would say f of 2, let me get a different color highlighter actually. There we go. So we have f of 2 right here would be equal to that looks ugly, but I would say 33. And now because I have a real world scenario, I have to be specific and write on there 33 feet. Now, the next thing that it's asking me to find is f of 4. So that means I need to go to 3 and then skip over to get to 4, right? Okay, so let's subtract another half a foot. That would be, oh gosh, 32.5. It's looking bad. I understand this. Let's take off another, and that would be, 32 feet. Okay, so f of 4 being my input, I would write over here 32 feet. Now, Alexis had given us a really great way to get these answers a little bit quickly, and she used multiplication. Now, in this case, gosh, it doesn't seem as easy because this time we're kind of subtracting. So I don't think multiplication would work. Gosh, it's almost as if we would need to build some sort of a function. Interesting. So what it looks like we're doing is, it seems like we're taking our initial amount over here, that was 34, and each time, every day, we're subtracting our 0.5, which I'll put as 0, just so that I don't forget that there's this little decimal there. We're taking off half a foot every day. So over here, I'll put D, just so that you don't forget, that's D for days. So for my first day, I said that was 34, and then minus 0.5 of 1 day. And then that was equal to 33 and a half. But here I had 34 and then minus 0.5. Sorry, I'm trying to fit it all in here. Let me make that a little bit bigger. Okay, but this time for 2 days, that was my new input. So here for f of 7, well, let's do the same thing. We would say 34 minus, there we go, 0.5. And then this time we would have 7 days. Now that maybe without a calculator would be a little different, but think of it like money. So if I have $7 and I'm trying to split it in half, well, for sure everyone would get 3, but then I have this one here that I need to split in half as well. So that's the same as saying 3.5. So our final answer here would be 30.5. Now, this f of 10, what does it mean in this scenario? Well, what we would have here is 10 is our input, so it's talking about 10 days. After 10 days, my water level would be blank feet. That would explain what f of 10 means in the scenario. So let's move on to some graphs. Now, Lucky, he's a visual learner, and so he didn't really like the table very much, and he turned it into a graph instead because graphs kind of make a little bit more sense. Now, if we were to look for f of 4 given this graph, remember 4 is our input, and our input means X. So that's our bag of treats. Here's my 4. So to figure out what f of 4 is, that means how much would 4 bags of treats cost? Well, let's go over to the 4 and oh, look, here we got a little circle right here. And then we come across over to our total price, and that says that it would cost $10. Well, that's pretty easy. So like I stated, what does that mean? 4 bags of cat treats cost $10. Duh. Now, this one's really important. This graph we would call discrete. Now, we would call it discrete because it is disconnected. So you notice how I have this 1, let me try that again, 1, 2, 3, 4, 5, 6 dots here. These 6 dots are not connected with a line. I would say that they are disconnected. So therefore, they are discrete data on a graph. Discrete means disconnected. There are no defined values between these 2 points. Why? Well, because I can't just be like, yo, I'm a cat, I'm gonna take whatever I want, and I'm gonna take 2.5 bags of treats and just leave all those other little fish-shaped things all over the floor and only pay for half of a bag. No, that's not gonna happen. You can't go into the store and be like, I only ate half the bag of chips, so here's 50 cents. Not gonna happen. Discrete data, it has to be whole numbers. You can't cut them into parts. Now, let's move on to a different type of graph here. At a store, carrots cost 75 cents per pound. So, oh, look at that. That looks nice. Again, we have here is our input, because that's our X. Duh. What was I even saying? Hello. Number of pounds of carrots is going to be my input, and that affects my output, my total price. Okay, that looks, hey, this graph looks different from the last one. So first question, f of 6. What's my input? 6. Let's find 6. Okay, there we go. Okay, so what does this mean in this scenario? Well, just like last time, I came over to my input to where it's 6, and, let's see. Boop, 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 boop. And it looks like, so that would mean that 6 pounds of carrots cost $4.50. Oh, look, there we go. We got our little animation going. I didn't have to do all that. All right. So there we go. There's our $4.50. Do remember that. So again, 6 pounds of carrots cost $4.50. Pretty easy. Now, like I had said, this graph is different. Ooh, look at that. So pretty. This graph is called continuous. Now, notice that this looks very different from this over here. So this graph, look at this. I have, you know, little points and they're disconnected. And then whenever I come back over here, even the writing looks different. This is in cursive. Look at how beautiful that is. Oh, that continuous. And this time, now notice that I bolded some letters. C-O-N-T. And I also bolded them over here in the word connected. Continuous means connected. Now, in comparison, to our last graph where I had something like a little bit of information right here, right here, right here, right here. Now, this time, I don't have little dots, bits of information. This time, all the information is connected and it's streamlined. So that means I could cut it in half. So, technically, that means that I don't need whole numbers. I could, if I wanted, I could even purchase, if I wanted, like, I don't know, 4.5 pounds of carrots. I don't know why I would need 4.5 pounds, but if I wanted, I could, and I wouldn't get in trouble. I would just put it into that little basket that they have in HEB and like push the buttons, you know, if they have those little stickers. If not, I just have to look at the scale and I can measure 4.5 pounds if I wanted. So the difference between continuous and discrete is continuous is something that I can measure it using fractions, but discrete, I have to count using whole numbers. Remember, we can't go into the store and buy half a bag of chips, but I can go into the store and buy half a pound of carrots or broccoli or things that I don't want to eat. All right, so let's try this out. Given the graph to the left, what do you guys think? Continuous or discrete? Connected or disconnected? Well, I would say connected. It's continuous. Now, f of -4. So again, this is my x. So let's go to the x-axis and locate -4. Now, negative is going to be over here. So it looks like my answer would be 2. Wow, that looks ugly. Okay. Now, this one is a little weird. This time, if my x is 0 right over here, my y is, it's over here. It's -4. Well, that wasn't bad at all. Okay, I was freaking out over nothing. But let's look at the graph to the right. Connected or disconnected? Continuous or discrete? Yeah, this one's disconnected. It's really obvious because, well, it's just dots. They're not connected. I think that I will let you guys try and figure out what is f of 7 and what is f of 3. Pretty easy, right? Okay, I'll go ahead and move forward. All right, so last bit. Here is a graph, and I want you to find the following function notation. Sorry, I don't even know what's going on. All right, so the first problem that I gave you is f of 6. So my input is 6, and I want you to find what would be the output. Also find it for f of 0, f of 2, and f of 5. Now, this one I'm going to ask a different statement. So what if my output is 4? All right. So given an output of 4, what's my input? Okay, that's what I'm asking on this last one. Now I'll give you a quick minute just to take a look over. F of 6. Okay, I found my answer. F of 2. Okay, ooh, that one's a little difficult. F of 0. Pretty easy. F of 5. You have to think about those two a little bit, huh? And I'm sure you guys all have this bottom problem here. Okay. Now, lastly, here's a little bit of practice because I feel just as tired of my voice as you guys do. All right, so here we have a table. We have a boy's age, and it says 2 years, 3 years, lots of years, and his average height in inches. So use the table to evaluate the function at each value. So I've given you f of 7, f of 4, f of 11, f of 12. Okay, now let's work backwards. For what value of x is the statement true? F of 6 equals 61. Okay, so I see 61 is my output, so let's go to my output. Oh, here's 61, and it's asking what's the input, because right now it still has x as blank. So for what value of x, so I would answer it as x equals, in this case I would say 13 years. I'm going to try my best to abbreviate years because, whew, I'm not going to write the S. I've already seen what my S's look like. I'm not going to do that to y'all. All right, so I'll just leave it right here for just a moment. If you'd like, go ahead and pause it, take a look at it, because tomorrow's assignment, you're going to have problems just like this. Please send me an email, maybe a remind text message, and let me know if you're struggling, if you need some help with this, okay? We'll take it a little bit slower tomorrow. Thank y'all very much.